Hi, welcome back to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 9 math Fryer contest question, and in it we have 4 parts. All of them have to do with this reverse operation, which reverses the order of the first n numbers in a list. We have parts A and B. We also have part C, which has 2 parts of its own. And finally part D, which says to determine the minimum number of reverse operations that need to be performed on this list so that the last number becomes 4 and the second last number becomes 5. You can skip to any of the solutions in the chapters using the timeline below at any time. Otherwise, I'll be right back with all the solutions. Alright, so let's look at question A. Question A says R3 is performed on this list. 5, 2, 3, 1, 4, and 6. And it says, what is the new list? So let's look at what this reverse operation is. So what it does, it reverses the order of the first n numbers. So in this case, n is 3. And so it's going to reverse the first 3 numbers. So what's going to happen is 5, 2, 3 will be reversed, and it will be 3, 2, 5. Now the rest of the numbers aren't going to change. And so the answer for part A is this. Alright, let's try one that's a little bit more challenging here. B. So B says a reverse operation is performed on this list. 1, 2, 3, 4, 5, 6. And then a second reverse operation is performed on that resulting list, giving the final list of 3, 4, 2, 1, 5, 6. And it wants to know what 2 reverse operations were performed and in what order were they performed. Well, what we can see right away is the last 2 numbers don't change. So it'd be reasonable to assume that the operation was R4 or less. So let's try doing R4 to start with. So if we did an R4 on this first list, it would then become 4, 3, 2, 1, and we still have 5 and 6. So now you can see 2, 1 and 2, 1 are in the same position. What happened now is 4 and 3 get reversed. So the second operation then would be an R2 operation to get that final list. Alright, part C says suppose that M is the minimum number of reverse operations that need to be performed on the list 1, 2, 3, 4, 5, 6. So that 3 ends up in the very last position. Alright, so a couple of things we're going to need to think about is 1, how do we get that last digit to ever move? The only way it will ever move is if we do an R6 operation, in which case the 6 will switch out with the first digit. So what we need to do then is we need to get that 3 to go into that first position. So we're going to start by doing an R3 operation. So when we do an R3 reverse operation, we're going to end up with 3, 2, 1, and then 4, 5, 6. So now if we do an R6 reverse operation, 3 will end up in our final position. We will get 6, 5, 4, 1, 2, 3. And this also answers part 2, where it says to explain why fewer than m reverse operations can never achieve the desired result. Here it took us 2 reverse operations, so m equals 2. To do it in any fewer than 2 is not possible. The only thing fewer than 2 would be 1, and if you were to do an operation which would remove that last digit, the only operation you have is an R6 operation, and it will be replaced with a 1, not a 3. Alright, so we move on to our last question, part D, where it says determine the minimum number of reverse operations that need to be performed on 1, 2, 3, 4, 5, and 6, so that the last digit is a 4, and the second last digit is a 5. We don't care about the other digits. So what I'm going to start with is an R5 reverse operation. This is going to lead me to 5, 4, 3, 2, 1, and 6. And I did that because I want 5 and 4 in the beginning because I want to move them to the end. In order to get this 4 into the first position, I am going to switch them with an R2 operation, which gives me 4, 5, and then 3, 2, 1, and 6. So now I can get 4 and 5 into the positions I want with one last operation, an R6 operation, which gives me 6, 1, 2, 3, 5, and 4. So it took 3 operations to get the desired result. You can't do it in any less number than 3. However, there is a different 3 operations that will give you this same result. Can you figure out what they are? Let me know in the comments.